Welcome back for Chapter 4, Lesson 9. We're going to be talking about slopes of parallel and perpendicular lines today. So, two lines are parallel if they lie in the same plane and have no points in common. And basically, the lines will never intersect. So, parallel lines look something like this, right? They just go on and on forever and never intersect. So those are parallel lines. Now, parallel lines actually have a few characteristics. So parallel lines, these are the two things you need to remember about all parallel lines. They have the same slope is the first thing. And the second thing is they have different y-intercepts. Different y-intercepts. So today we're going to be identifying which lines are parallel. And so we're going to be looking for these two characteristics. We're going to be looking to see if they have the same slope and if they have different y-intercepts. And if they do, we can be like, oh, they're parallel lines. So let's go ahead and get started. So we're going to identify which lines are parallel and then graph the lines that are parallel. So we're looking here at these three equations, linear equations, and we're just going to, okay, we need to figure out first what lines have the same slope. So we need to go ahead and determine the slope. It's nice because these are in slope-intercept form, right? Y equals mx plus b. And so we can tell, right, y is isolated, so we know that the slope here is equal to -2. All right, this one is also in slope-intercept form, so we can tell that the slope is equal to 3 here. And then right here, this is also in slope-intercept form because y is by itself, and so we can see that the slope is -2. So it's pretty obvious that these are the two that have the same slope. But to be parallel, you need one more thing. They need to have different y-intercepts. So for these two, let's go ahead and determine what those y-intercepts are. So here, right here, because it's in slope-intercept form, we know that the y-intercept here is 4, and over here, the y-intercept is -1. So that's awesome. They have the same slope and different y-intercepts. So we know that these two lines right here are parallel. These lines are parallel. Okay? So now, I'll just say y equals -2x plus 4 and y equals -2x minus 1 are parallel. Now it's just time to graph those two lines and then we can see how they're parallel. So the first one, the y-intercept is 4, and then the slope is -2. Remember, that's a fraction, so -2 over 1. So down 2 over 1 is right here. Down 2 over 1, down 2 over 1, down 2 over 1. All right, where's my straight edge? Here you are. Then we just need to connect those dots. Okay. Dots are connected. All right, so that is y equals -2x plus 4. And then we just need to graph this second line, which is the y-intercept is -1 here. So we always graph that first, and then the slope is -2 over 1, right? So down 2 over 1, down 2 over 1, and then we can do the opposite, up 2 over 1 this way, up 2 over 1 this way. All right, and then time to graph. Connect the dots. Come on. Oh, I didn't really connect those dots very well. Hold on. Well, you're going to have to make it a bigger line. It was more like this. There we go. Put arrows on the end. It just all kind of cleans up right there. And if you can see, this is, what was this? This was y equals -2x minus 1. The lines are parallel. They're just going to run side by side forever and ever and never intersect. So same slope, different y-intercepts. All right, perfect. Let's go ahead and look at another example. So we're just going to identify which lines are parallel and then graph. So, right, we need the same slope, different y-intercepts. So here, what's this? Okay, the slope is, it's in slope-intercept form, which is perfect. So we know the slope is 2. This x equals -2. So x equals -2 is going to actually be a vertical line. So with vertical lines, the slope is undefined. Oh, we have another vertical. Oh, it was -2. I'm sorry. X is -2. X is 5. That's another vertical line. So the slope would be undefined. And then here we have a slope that is m equals 2. So it looks, okay, so we know that these are parallel because they're both undefined. They're vertical lines. And so we can actually graph those. So x equals -2. X is right here, -2. This is x equals -2. So x equals -2. And then x equals 5. This is when x is 5. X is 5 all along here. So you see vertical lines are always parallel to each other. So all vertical lines are parallel to, oh, that's supposed to be a 5. What is wrong with you, Joy? But that's okay, fixed it. Yeah, all vertical lines are parallel to each other unless they're the same vertical line, right? But as long as they're different vertical lines, they're all parallel. And the same is true for horizontal lines. All horizontal lines, as long as they're different horizontal lines, are all parallel to each other. Okay, so that's that set. So I'm just gonna put those in pink, just saying, hey, those are parallel. And I can actually write my answer like this. X equals -2, and then they have these little lines like that, and that means parallel. So x equals -2 is parallel to x equals 5. Okay, and that's kind of like my pink set, right? But what do we have here? We have, oh, I hate how it gets blurry. Anyways, oops. So, but then we had these two right here, which had the same slope. Okay, so we have the same slope here. Let's look at this a little further. What do we need? Same slope, different y-intercept. So what's the y-intercept? The y-intercept here would be +1. And the y-intercept here, it's nice because it's in slope-intercept form, right? Y equals mx plus b. So the y-intercept here is -3. So wow, we actually have two lines. These have the same slope and different y-intercept. So that means they are parallel as well. So this line is parallel to this line. So I can just go ahead and write that and say y equals 2x plus 1 is parallel to y equals 2x minus 3. Okay, and then let's just go ahead and graph them. So I would highlight that, but I'm actually trying to be smart this time and give it the ink a little bit of time to dry so it doesn't do the smear. But we'll see if it works. Okay, so let's graph this one first. +1, y-intercept is 1, and then that slope is 2 over 1. So up 2 over 1, up 2 over 1, opposite from down 2 over 1, and down 2 over 1. All right. Okay, hopefully I can draw a line good. I should have put these in a different color, but that's okay. So even though this intersected with this particular line, this pink is parallel with this pink, okay? And so we're gonna make this yellow and it's gonna be parallel with the yellow. So we just have two sets of parallel lines. So please don't get hung up on the fact that because this is not parallel to this. Yeah. Okay, now let's graph this one. -3, down 3, and then slope is up 2 over 1, up 2, 1, 2 over 1, up 2, 1, 2 over 1. Okay, graph it. Perfect. Okay, now I'm just gonna highlight. So those are clearly parallel, right? You can see that. Still smear. It's like I can't get away from the smear. And this one's really gonna smear. Well, wasn't that bad. Okay, well, let's see if there's any left over. Yeah, there's some residual. Okay, so there we have it. Those two lines are parallel. So in this one, we actually had two sets. That's kind of fun. Okay, let's look at the next one down here. Next example. Ooh, we have some different forms here. This is point slope form, but that's cool. We can still determine what the slope is, right? So remember, point slope form is y minus y1 equals m multiplied by the quantity x minus x1, right? Okay, so the slope for here is 6. So m equals 6. That's the slope. All right, what about this? Ooh, this is a special one. Do you know what this one's called? This is a direct variation. This is y equals kx, but k is the same thing as the slope. So we know that the slope here is actually equal to m equals negative 6. All right, all right. What do we have here? Y equals 6. So that is when y is equal to 6, 6, 6, 6 right here. That is a horizontal line, which means the slope is equal to 0. And what about this one? Ooh, we can't figure out the slope because this is in standard form, right? Remember ax plus by equals c? So to determine what the slope is, we actually have to put this into slope-intercept form, which is y equals mx plus b, right? Which means we just need to solve this and get it equal to y. So let's go ahead and do that. So we're just going to do the opposite of this positive 6x, which would be negative 6x. Since I'm trying to put this into slope-intercept form, I'm going to make sure that I write this negative 6x because that's kind of like my y equals mx, and then I'm going to write my plus b over here. Okay, great. So now it's in slope-intercept form, y equals mx plus b, and then I'm just going to write down what my slope is, which is negative 6. Okay, okay. Now I need the same slope. What has the same slope? Well, this has 6. Is there a 6? No. Negative 6. Ooh, negative 6 and negative 6. Those are my parallel lines. Woohoo! Okay, well, they're not parallel. Joy, what is going on with you? Because what do you need for parallel lines? You need the same slope and different y-intercepts. Okay, so we have the same slope. We have to determine that we have different y-intercepts. I don't know what I was thinking. Okay, so this is a direct variation. We have to find the y-intercept. What do we know about all direct variations? What's the y-intercept? They all pass through the origin, which means the y-intercept is 0. And you know that because there is no y-intercept out there. And by there not being a number, there is a number, and the number 0. So the y-intercept is 0. And then over here, y equals mx plus b, the y-intercept is equal to 4. Oh, we have different y-intercepts. Woohoo! That means these lines are parallel. Okay, I need you to just appreciate this. I'm going to try to be smart. This is me attempting to be smart. So I'm going to write that these two lines are parallel, but I am going to try to be smart and highlight it first so then my ink doesn't smear. Let's see if this works. Okay. So we are going to write y equals negative 6x is parallel to, and I'm going to use this original equation, not the one that I put into slope-intercept form. 6x plus y equals 4. And it worked! Okay, I'm so excited about that. All right, now it's time to graph. Okay, let's do this one first. Y-intercept is 0. Okay, and then this is negative 6 over 1. So from 0, we're going to go down 6 over 1. And yeah, then I'm going to go the other way. Up 6. Up 6 and over 1 that way. I wonder if I should try to be smart again. Let's try to be smart again. Let's just highlight this in pink first. We'll see. This is all an experiment. I know those like little points are going to see they totally smeared, but it's not as much smear. You know, it's still smearing. It's totally smearing. You know, I don't know. I need to have a better relationship between my gel pens and my highlighters. I don't feel like they're functioning very well together. It's like they're in competition. It's like the gel pens get jealous and they're like, of the highlighters, and they're like, I'm gonna show you when you try to highlight me, I'm just gonna smear everywhere. I don't know, that's just me being silly. But if there was a cartoon about it and the gel pen had a personality and the highlighter had a personality, I feel like that would be the character, right? The gel pen would be kind of like trying, like they feel like the highlighter always steals all the attention. Like the highlighter's trying to show off all the time. I don't know, maybe I'm going into this a little bit too much. Okay, anyways, moving on. Back to graphing this one here. I don't know, did that really work? I mean, what looks better? I really think that looks better than this. This is me trying to make it look better, and it looks like a hot mess. How does it smear more? It had to be those 3 points. Yeah, I just feel like it looks worse. I don't know. Anyways, okay, so we'll go back to the first method. However, this worked. This was a good relationship between the highlighter and the pen, I felt. Maybe you think differently. That's okay. All right, so let's graph this one. Up 4. up 4 here, and then down 6. 1, 2, 3, 4, 5, 6 over 1. Ooh, these are going to be so close. 1, 2, 3, 4, 5, 6 over 1. These are going to be really close. It's almost like my highlighter could have handled both. Let's go up the other way. 1, 2, 3, 4, 5, 6 over 1. Okay. Oh, these are going to be like super duper close. All right. Okay, let's see if I can line this all up correctly. You would think it wouldn't be that difficult. Oh yeah. Look at that. They're just cute. Those are two cute little parallel lines. Look at how close. These are like little buddies, okay? So in my little gel pen highlighter movie, that cartoon animation that I'm thinking of in my head, these parallel lines would just be friends. They would be really good friends. They just like, you know, it's like they can never intersect, but it's like if I can never intersect, I'm just going to be as close to you as possible. Whereas these ones, these parallel lines are like, get away from me. Okay, I know we're parallel, but I don't want to be close to you. I'm going to be far away and part. So I don't know. These ones, these parallel lines are like not friends. These ones, this is probably like a healthy friendship. Just like, I'll give you my space, you take my space. These ones are like, I have to be around you all the time. I just love you so much. Okay, I'm sorry. That's enough of that. Okay, now it is your turn to check it out. I want you to solve these problems. So 3 and 4. Go ahead and solve those. Identify the lines that are parallel, then graph. Where's my friend? This is my friend, the Pause Dragon. Go ahead, work those problems out. Make sure you pause your device. When you get done, press play and we'll talk about them together. All right, see you in a bit. I totally just threw the Pause Dragon. I went, ah! Oh, sorry, Pause Dragon. I'm sorry to abuse you. Okay. All right, let's see how you did. We got to see what's parallel. So we got to find slopes, y-intercepts. All right, this is in y-intercept form. That's the slope. M equals 3. This is a, what is this? Y equals -4. Horizontal line, so that means the slope is equal to 0. This is a, ooh, direct variation. All right, all right. So the slope is the same thing as k, which is 3. And then what is this? Ooh, y equals -2. Which is a horizontal line, which means the slope is 0. Oh, so we have 2 horizontal lines. And so that means that they are, I'm going to use another color. They are parallel. I'm going to graph those first. Watch this. I'm going to try to be smart. Okay, so y equals -4, boom. And y equals -2, boom. They're both parallel. Okay, okay. And then I'm going to do this. Okay. Joy's trying to be really smart. Okay, okay, okay. So what are we going to say? We are going to say that y equals -4 is parallel. I love writing these instead of writing the word parallel. It just brings me so much joy. And the fact that Joy is my name, I don't even know. I'm not even going to finish that. That was not going anywhere. That's just me talking about nonsense. All right, so there we go. Then we graph them. You know what? I didn't even use a straight edge on that, but I think it turned out pretty well. Oh, they're so beautiful. And I feel like this is a healthy relationship between parallel lines. So, you know. Okay, what's the next one? Okay, we have the same slope. Now we got to find the y-intercept. So y-intercept there, 1. Y-intercept here. Direct variation means the y-intercept is 0. There's nothing there, but there is something. That nothing is 0. Okay, now it's time. Oh, I'm going to go a different color. What are we at? Y-intercept, so I'm going to do this one. You know what? Let's go ahead and just highlight first. We're highlighting. Oh, man, see, this is like residual from the last problem. Look at that. Or maybe we'll just say it's like a new thing. It's like an ombre highlighter. I don't know. Okay, and then what's this? +1 would be here. And then what are we going to go? Up 3, 1, 2. I'm graphing this one. 1, 2, 3 over 1, and then down 3, 1, 2, 3, oh wait, 1, 2, 3 over 1. That's my graphing voice, 1, 2, 3 over 1. I think that's right, 1, 2, 3 over 1. Yeah, and then we just graph it like that. Okay, All right, I don't know why I'm enjoying this so much. Okay, these ones are parallel, and then we got to graph this one, but that's just, oh, these ones are really going to be like BFFs. Y equals 3x plus 1. I totally said I was going to do it in a different color. Y equals 3x. I'm just going to make this like a really big highlight because that's what's going to happen. This is what's going to happen. These two lines are going to be BFFs. And let's use a different color. So we have plus 1, up 3, 1, 2, 3 over 1. So we have 1, 2, 3 over 1. Okay, and so we have that line. Ooh. Okay, right here, boom. And then we have this line, which the y-intercept is 0. These are going to be so close. 1, 2, 3 over 1. Look at, oh, can't do it that way. 1, 2, 3 over 1. All right, these are even going to be closer. Like, I'm never going to leave your side. They're like, you are the best friend ever. No, you're the best friend ever. Oh my gosh, you're the nicest person ever. No, you're the nicest person ever. Like, I feel like that's what these two parallel lines, that's what their conversations are like. Yeah, there we go. So if you got that right, great work. Make sure that you identify that the lines are parallel. This is a part of the answer here. Okay, now on to this other one. Let's see how you did. Okay, what are we doing? All right, parallel lines, same slope, different y-intercept. So this is in, what is this in? Point slope form, right? Right. So that means that the slope for this one is right here. It's a negative, which means the slope is -1. Ooh, why didn't I write, okay, -1. Ooh, it's just not a great -1, okay? That's not my best. Okay, then this is another direct variation, y equals kx, the slope. K is the same thing as a slope, right? And the slope is in front of x, and it's just a negative, which means it's -1. Okay, what is this? This is another direct variation. It's a direct variation party. Okay, so y equals kx. K is the same thing as slope, so the slope is equal to 3. And then, ooh, the standard form. I don't even know what the slope is, so I have to do some work. Got to get y by itself, so it's okay. I can do this. I can do this work. Oh my goodness. Another slope of negative? Are you serious? Dang. Okay, y equals mx plus b. So this is the slope. It's a negative. It's -1. Wow. That is a lot. That's a lot. A lot. I'm sorry, but you are not the winner. Okay. We have 3 different things that have the same slope. This is very, very interesting. Very, very interesting. Okay. So now we need to determine what the y-intercepts are. So I'm going to start this way. Y-intercept is 3. So b equals 3. Y-intercept here, direct variation. There's nothing here, but oh wait, there is. Nothing represents 0. So the y-intercept is 0. And then this one over here, oh my gosh, I have to do so much work. We have to find the y-intercept, but we have to put this in slope-intercept form. So I'm just going to rewrite this. Okay, we can totally do this. We have to distribute this negative first. Distributing the negative. Negative times x is negative x. Negative times 7, negative 7. And then we got to get y by itself, so I'm going to add 1 to both sides. Negative x, and that's -6. All right, so we have the slope equaling -1, and the y-intercept, because this is y equals mx plus b, is -6. So we have different y-intercepts and the same slope. Wow, we have 3 parallel lines. Oh my goodness. This is so exciting, so exciting. Okay, I need a special. We haven't used orange. Orange. It is your debut for this video. There we go. There's orange, your parallel, and your parallel, and your parallel. Let me just make sure. We are. I didn't even anticipate this. This is so exciting. Okay, and we're going with purple. Okay, so this one first. -6 here, and down 1 over 1. Down 1 over 1. Up 1 over 1. Okay. Okay. All right. Oh my goodness. I feel a sneeze coming on. I'm trying to fight it though. Have you ever tried to fight a sneeze? It sometimes hurts, like your nose and stuff. But I'm trying to fight this. Okay. It's not happening. I think I did it. I think I conquered the sneeze. Okay, let's graph this one right here. So y-intercept is 0. Down 1 over 1, down 1 over 1, down 1 over 1, up 1 over 1, Okay, time to graph the line. Okay, there we have it. Okay, and then this one right here, the y-intercept is 3. 1, 2, 3. And down 1 over 1, down 1 over 1, slope down 1 over 1, up 1 over 1. Okay, we can graph this one right here. Okay, and look at, they're all 3 parallel. They're all 3 friends. These ones are closer together than this, but that's okay. It's a healthy relationship. All right, so this is, what is this? This is the line y minus y, y minus 1 equals negative x plus 7. This one is y equals negative x. This one is x plus y equals 3. And then we just need to write our statement that they're all parallel. And this is going to be so fun. I'm so excited for this statement. It needs to be very long because it's just going to be this is parallel to this, which is parallel to this, which is parallel to this. Okay, it's like a teaser. Y minus 1 equals negative, multiplied by the quantity, x plus 7, which is parallel to our lovely direct variation, y equals negative x, which is parallel to x plus y equals 3. And so if you got all of that right and you have your statement written, these just need a little orange. They just need a little orange highlight in their life. Then you are amazing. You did a wonderful job. Remember, parallel lines have the same slope and different y-intercepts. And that is it for this lesson. So I will see you in a little bit. Not the lesson. That's it for this example. I'll see you in a little bit for the next example. All right, see you.